Hi, I'm Deepthi and today we are diving deep into the fascinating world of sentiment analysis using deep learning. Sentiment analysis is a field of natural language processing that allows us to understand the emotions, opinions, and the feelings expressed in textual data. In this video, we are going to explore how deep learning, with its powerful neural networks, can help us unlock the sentiments hidden within the text. But why is sentiment analysis such a big game changer? Imagine being able to automatically determine whether a review is a positive one or a negative one, or if a tweet is expressing joy or frustration. These insights can be a gold mine for businesses, researchers, and decision makers, right? In this video, I'll guide you through the fundamental concepts of sentiment analysis, right from the model building, the data preparation to the model building. We'll walk through the code, discuss the best practices, and share some real world examples that will help you to understand and apply the sentiment analysis effectively. So, if you are ready to embark on this exciting journey into the heart of sentiment analysis using deep learning, I encourage you to please engage with this content by leaving a thoughtful comment or a question below. Your insights and feedback are highly valued. So, let's get started.
So let's dive deep into the journey of sentiment analysis with deep learning. This is the table of contents for our session where we go through the image processing, the introduction, the application challenges, and how deep learning works. So you might wonder what image processing has to do with sentiment analysis. But sentiment analysis is all about teaching computers to understand the feelings in text, like identifying if the review is a positive one or a negative one. But image processing is about analyzing pictures, right? But how they are related is that we want to analyze both the text and the images together, like when checking how a person feels about a product based on their reviews and photos. So, combining these techniques gives a more complete picture of people's sentiments and opinions. So, image processing is like a special computer and a tool to make the picture look better, or to get important content from it. What are the operations in image processing? So these are the steps. First, we have to acquire the image from various databases, digital cameras, scanners. This is image acquisition. Next, we move on to pre-processing the image, which involves cleaning and preparing the acquired images for further analysis. We use this in medicine, looking and also looking at faraway things in security also. Image enhancement is to improve the visual quality of the image such that we can look at the image and it appears more visually appealing to us. So here are the two techniques, that is the point processing and spatial processing techniques, which are used to enhance the image. So this is the code for pre-processing. First we read the image, we resize it, and then we display the pre-processed image. There are various image restoration techniques which are used to remove the noise. The noise is such that the dots on the image, these are only called as noise. So this can also be removed by classifying it into two categories, that is the spatial domain and the frequency domain. Image filtering is the next step, which involves tools to change how an image looks. We have different filters like low pass filter to smooth out the bumpy parts, high pass filter to make the edges look sharper, and band pass to pick out certain detail. It's like using different brushes to paint a picture. So this is the code for filtering using Gaussian blur. Now, what is image segmentation? It's like the name suggests, it's dividing a picture into different parts so that it becomes useful for recognizing certain objects. So, feature extraction, which is the next seventh step, which involves and it means finding important details in an image. like edges or textures, which helps in understanding and classifying what's in the picture. Next comes the object detection and the recognition. So we have to find and name things in pictures, right? Which is only then useful for recognizing faces or objects in self-driving cars, which is done using smart algorithms. Image compression is making images look smaller but keeping the important stuff, like using a magic trick to save space when storing or sending pictures. The 10th step is the morphological operations. These are the special image tools for changing shapes like stretching or shrinking. This is also helpful for removing noise or studying objects in photos. Finally comes the image analysis, which is very useful for figuring out useful things from pictures like recognizing patterns or textures, which is great for tasks like sorting images or tracking objects. Now this is the example. This is the image captured from the Hubble telescope which was launched in 1990, which can take images of very distant objects. However, some images taken by this Hubble telescope were found to be useless. So image processing comes into the picture and some techniques were used to fix this. So you can see the blur is removed here. And also, this is another application for medical images. So this is an MRI scan. You can see the before original image of the dog heart here, but the edges are not shown. So after the edge detection, see how the edges are highlighted with white in color. So suitable filters are used to highlight the edges here. Finally comes the noise filtering. As I told you earlier, two types of noise is found in this picture. So white and black. These are also called as salt and pepper noise. And noise filtering is used to remove the dots which is blocking the wave space. Image deblurring is an example shown here on how the filter is applied on making this image deblur it. This is also an example on how important image processing is and how it enhances the image. So you can look at the aerial and satellite images taken and how it is used to improve the quality and it removes the noise. You can see how in the X-ray the bones are highlighted and also in this the filter is used and it improves the quality finally. So how and what machine vision is applied here? So it is essential to extract the image and the information from the image so that it is useful for computer processing. As we saw earlier, those were the typical applications and law enforcement also. So with that and how we capture the image, then only it can be used to run the number plates and can be used in some computer algorithms for fingerprint recognition, for the enhancement of the theft also. And how it is used here, that is the human computer interaction to make it more natural to recognize the faces. So this is an example here. Finally, in conclusion, image processing's growth extends to sentiment analysis using deep learning, enriching our ability to understand emotions in both text and images. As technology advances, we anticipate more powerful tools for comprehensive sentiment analysis across varying domains. Let's move on to sentiment analysis using deep learning. Sentiment analysis is the process of determining the emotional tone behind a piece of text, such as a sentence, paragraph, or a document. Deep learning has proven to be highly effective in sentiment analysis tasks due to its ability to automatically learn hierarchical representations of data. So why deep learning is beneficial for sentiment analysis? Deep learning is perfect for big scale real time tasks like social media monitoring and customer feedback analysis. They can handle complex data structures such as natural languages and can learn from vast amounts of unstructured data without the need for manual feature engineering. So deep learning models can continuously improve the accuracy as they are continuously exposed to new and new data, which makes them ideal for sentiment analysis, such as social media monitoring or customer feedback analysis. So how exactly is deep learning perfectly apt for sentiment analysis? Deep learning for sentiment analysis imitates the human brain using artificial neural networks where interconnected nodes help predict patterns in data and they help classify new text as positive, negative, or neutral. So deep learning models are generally trained with labeled sentiments on large text data sets. So they learn the patterns associated with these specific emotions that is attached and labeled on these sentiments. They classify the new text as positive, negative, or neutral. So let's dive deeper and look at the steps and the process involved for this. So these are the five steps which is displayed here. First is data set preparation and text pre-processing. Second one is word embedding. Third is model architecture. Fourth is model training and evaluation. Fifth is fine-tuning and regularization. Finally, the inference. So let's look at the first step. As the name suggests, data preparation and text processing. So what is data preparation? It is generally gathering or creating a labeled data set with text samples and the emotions also labeled, essentially the positive, negative or neutral. Now what is text processing? It is naturally the cleaning up of the text and making it neat so that everything is similar and in lowercase by handling punctuation and the special characters. We have to tokenize the text into individual words or subword units. Now under data set pre-processing, that comes another six subdivisions, which are we have to load the data set, clean the text, and how we have to tokenize it, the stopword removal, everything we'll look at further here. So what is text cleaning? The name suggests we have to clean the text and remove any irrelevant information, remove the special characters, the punctuation, so that these things are not relevant to sentiment analysis. Anything that are not related, we have to remove it, and other non-alphabet characters also. Tokenization is generally splitting the text into tokens or words. So how does it help? It represents text as word sequence. So this can be pre-processed and fed into the model. So there are many techniques for tokenization. Now in this code, we are using NLTK library. And furthermore, I'll show you how we are taking IMDb reviews dataset and how all the process is followed. The stop word removal, how we are removing the common words that does not carry any meaning, so that the articles, preposition and conjunctions are some examples. So these stop words are considered as noise and they can reduce the noise in data and actually improve the model's performance. So this can be used to make the model more effective. So what is word normalization? It is used to reduce the variations. For example, it involves stemming. That is, we have to cut and we have to bring the word to its base or root form. So running can be cut to run. Or lemmatization, which is also this equal to the dictionary definition. That is better is equalized to good. Vocabulary creation is building up a vocabulary from the pre-processed textual data. So we have to assign a unique index to each word. So that which helps in converting the textual data into numerical representation. So that then only they can be fed into the artificial neural network and then only this whole process can be done. And all the sequences, we have to ensure that all the words have the same length. So we have to pad it and use particular padding, which involves adding zeros or some special tokens to the end of some shorter sequences. We have to make it to equal length. And also concatenation comes into picture, whereas if a certain word is larger than all the other words, then we have to truncate it, which involves cutting off the excess tokens from the longer sequences. And finally comes we have to split it into the training and the testing step, so that the training set is used to train our model and the testing is used to evaluate how good our model is and how good is its performance. So the common practice used here is that the 80-20 split, whereas the 80% is used for training and the remaining 20% for testing. So after data set preparation and all the subdivisions under this, next comes the word embedding. So word embedding is which represents words as special numbers that grasps the word's meaning. Next, we have to choose the model architecture. We have a varied architecture, RNN, LSTM, BERT, and all the abbreviations are given here. And finally comes the training and the evaluation. So we have to split the data, train it, fine tune it to get the best results. Next, we have to evaluate and test our model on new data. Then only the evaluation comes into picture and how well it works, the accuracy. We can determine it using the F1 score, the precision, the recall, and everything else. Finally, we have to fine tune it and use it and get a particular information from it, which is called inference, which is finally putting our trained model to work, letting it analyze emotions in new text that we feed it to. So here we use a sequential model. Why do we use a sequential model? It's used suitable for tasks where the order of words in the input sequence matters. So this is the difference between the machine learning and the deep learning. There is a pictorial representation. In machine learning, how the feature extraction is done, we only use the one-hot encoding. Here we use a deep embedding and there is a hidden layer for to classify the sentiment into positive or negative. So what are the challenges and limitations of deep learning? So using this, it can be a bit tricky because we can't always understand why it makes certain predictions for some emotions. Also, it needs a lot and lot of labeled data, which can take time and money, especially for niche topics. So what are some applications? It can be used. Sentiment analysis using deep learning is like a superpower tool that helps in marketing, finance, politics, product improvement, security, and more. The conclusion is that deep learning, powered by sentiment analysis, is a valuable tool for deciphering customer emotions, and it also offers insights for decision making across various industries. Despite its challenges, ongoing advancements in deep learning technology continue to enhance its potential. I've collected the IMDb reviews dataset and I've imported all the essential libraries here. So the dataset is downloaded from the Kaggle dataset and it's named moviereviews.csv. So as you can see here, the reviews are written here and the sentiment is already classified and the information is printed here. So the texts are cleaned where we are removing the HTML tags, punctuation is removed and it is converted to lowercase. So one O is capital here and the O is reduced here. So this is a success. And from the NLTK library, the stop words are downloaded and it is applied to our data. And we are tokenizing the text here. Lemmatization is done. Finally, the vocabulary is created, the texts are vectorized, and it is padded accordingly, and it is also truncated. So here is the original review and our pre-processed review, you can look here, and the padded sequence also is displayed here. So we are defining the word embeddings and the analysis model is applied here. We are using the sigmoid activation function and the LSTM model is applied here. So the model summary is printed, the dropout rates, and the LSTM params. The Keras package is imported from the TensorFlow library, and the model architecture is defined. So it is evaluated and the accuracy is 86%, the loss is 35%, which is pretty good. So we are loading the model again so that we can classify a new text and determine its review. So let's see how it works. So the how the text that we enter should be pre-processed. This is the new text. This is an amazing show. So what do you think this is going to be? So first we have to pre-process it, right? So the case is converted to lowercase, the special characters are removed, tokenized, stop words, lemmatization, everything is applied here. Finally, the model is loaded and the sentiment is positive, which is correct with a score of 77. So this is a review is positive. Yeah, it's correct.
Welcome to this exciting journey into the world of Infolink. And yes, that's the title of our project, Infolink, connecting citizens to government. Today we are going to explore how our project is revolutionizing the way citizens connect with their government using the cutting edge technology. We've all been there, right? Trying to navigate through government websites, filling out complex forms, or seeking information about government services, which is a daunting task. I remember myself searching when I turned 18, actually, to search on how to get a driver's license and on how to update or change an address or how to update to a new address in my Aadhaar card or driving license or how to apply for PAN card. So this is a daunting task, as I told earlier. That's where Infolink comes in. Infolink is not just a project, it's a bridge between citizens and government services. And it's powered by some incredible technologies like BERT architecture and LLM, large language model, which I'll explain in just a moment. Now, you might be wondering what's this BERT architecture? BERT stands for Bidirectional Encoder Representations from Transformers, and it's a state of the art NLP processing model. It's like a super smart language understanding machine. When you ask or seek information on Infolink, BERT goes to work. It understands the context of your question, takes into account all the words in the query, and finds the most relevant answers from the vast data set. It's like having a conversation with the computer that really gets you. But wait, there's more. We're not just using any LLM, it's harnessing that is similar to the power of GPT 3.5, which is a model developed by OpenAI. This model has been trained on massive amount of text data, making it incredibly smart at understanding and generating human-like text. Here how it all comes together. You, the citizen, ask a question in plain language. Infolink powered by BERT and ChatGPT, like that is the LLM model, your query and understands what you're looking for and then finds the most accurate and helpful information. And within seconds, you receive a clear, concise, and a personalized response. It's like having your very own government service assistant available 24 by 7, ready to provide information, guidance, and answers to all your queries. Imagine the convenience. Whether you're looking for information on taxes, the public services, many times we find ourselves looking for what law this is, like some law people use, right? This is section this or that, and about the tax or about the property tax, and we might not know what it means or what this particular law means. So, Infolink comes into picture, right? So, it makes our life easier. It's about giving you the power to access the government services at your fingertips. So that's Infolink, connecting citizens to government. It's not just a project, it's a game changer. Stay tuned as we dive deeper into Infolink and how it can transform the way you interact with government services, making them much more accessible and user friendly than ever before. So I'll unveil the inner workings of our remarkable project, Infolink. So our journey begins first with data collection. We amass data from all the government websites where they have the PDFs listed, their rules, the FAQs, all about the taxes, and all the information is available under the government websites. and the FAQs. This, however, needs refining, right? So we embark upon data pre-processing, a meticulous process of cleaning, standardization, and structuring. So enter the star of our show, the fine-tuned language model LLM. It's trained using our curated data, becoming a context-aware conversation master. So here's where this gets fascinating. Users converse with a virtual assistant naturally, trying or speaking their questions. The magic unfolds in natural language understanding. Our model interprets user's intent, context, and meaning, making sense of their queries. Next, the assistant goes and does the behind work. Finally, it's mining its dataset and external sources to find out the answer and gives it to give the accurate information. And the grand finale. The model crafts a particular response to the user's query, offering concise answers. Perfect, right? But the story doesn't end here. Users become co-creators, offering feedback to our system. Then only we can develop, right, with your feedback and with everyone's feedback. Then only this will be useful to all the citizens. Finally, our creation is deployed for all access on platforms like websites and mobile apps. In summary, our project fosters accessibility, efficiency, and scalability, fueled by a cycle of user feedback, all for the relentless pursuit of improvement. Thank you for joining today. Together, we are connecting citizens to government in a whole new way. Signing off.